Going to remember to click this button, share screen. The the recording I did second hour was just my voice. When I don't hit share screen, all you can do is hear my stupid voice. So I had to delete that and try again. So now you can see my screen. So this will be better. Let's get to it. So yeah, today is a cool date. It's 1/11/23 for your notes. 1/1/1/2/3. I appreciate you putting that phone away without me having to tell you there. I was thinking 5 seconds and you did it. So good job. Today we're going to be simplifying radicals and they're going to have variables on the inside. So same, it's kind of a piggyback off of yesterday's lesson. So to begin, we don't have to review everything from yesterday. We're going to talk about variable values like this. If I said to you, what is the square root of x squared? Do you have any thoughts on that? It's kind of an odd question to just throw at you first thing, but it is. The way square roots work is they are the undoers of exponents. And so I heard you say 1x, I think, right? That's just fine too. The way a square root works, or any type of root, says, I'll cancel your power. Powers and roots are called inverses. So always remember this, even though we don't put it, is called a second root. That little red 2, no one would ever write that. I mean, I just did, but the second root of something is called the square root. And it just so happens that this power of 2 and this index of 2, 2 divided by 2 equals 1. Therefore, the answer is x to the power of 1. What would be the next power of x that would be square rootable? Yes, you're a good listener. If I had x to the fourth, once again, if I understand that I'm dividing, yeah, we're rooting, I get that. But to root exponents, you actually divide the exponent by the index, and 4 divided by 2 is x squared. You start to, I hope, see an emerging idea that you can't expect good results if the index or the exponent on the inside is not divisible by the index, right? So we'll come back and talk about that guy. But in the meantime, I'm going to jump up ahead and get to some bigger numbers. What is the square root of x to the 16th? It is x to the 8th. And it's easy to want to say x to the 4th because you get excited and think the square root of 16 is 4. But remember, the 16 is an exponent and we don't root it technically. We divide it by the index, and 16 divided by 2 is 8. Are we good? And this same thinking, let me hop ahead before we get into the ones that aren't cooperative. Let's run through some higher order radicals like cube roots. And so what's going to be the first power of x that's cube rootable? X to the third, because the same idea applies. If my exponent on my variable inside can be divided evenly by the index, this is good. And the first number that you can divide by 3 is 3. So the cube root of x to the third is x to the 1. We just put x. Who's next to be cube rootable? X to the 6. And then, of course, I could hop way ahead and ask you for the cube root of x to the, I don't know, 99th. What's that going to be? X to the power of 33. So you got to just train your mind into saying, I'm not rooting the exponents. I am not rooting the exponents. And then you got to learn to keep it, as you'll see in these examples, you got to keep the how we treat the numbers that aren't variables with powers, and then how we treat the variables with powers. They're all having the same thing done. It just looks really different. So we'll just do like one more column of this, and then it's like, well, you get the idea. So fourth roots, same idea. Who's the first power of x that's fourth rootable? X to the fourth. Yeah, so it comes out nice. X. And after x to the fourth is x to the eighth. Good. So so on and so forth. So you good, right? So remember, the moral of that little 5-minute story is that you are dividing the exponent by the index of the radical. Which, of course, leads to the inevitable question, well, what happens when the numbers don't play nice together? Because, that's a big part of math is things just sometimes don't work the way we want. So how about the square root of x to the 49th? Remember, you don't give a rip that 49 can be square rooted. This is not that thinking. You don't see him as a number that you're trying to square root. What are you trying to do with 49? Divide it by 2. And that's where your brain kind of goes, hit the brakes, pump the brakes. This isn't going to work. So anyone from last year remember how we deal with this? It's the same as how we deal with numbers. So you'll remember, like, if I gave you the square root of 20, you know that what you do, we talked about this yesterday, is you take the number 20 and you break it up into 4 and 5. Because your thinking is, I hope, that 4 is square rootable, isn't it? 4 is what we call a good guy. And if 4 can break out of jail, then I've made progress. So I want to apply that same thinking on a much maybe weirder level. What can I do with x to the 49th to make him a really big good guy times a leftover guy? That. Yes. So what we're going to do is we're going to rely on some basic math knowledge here. And you guys all know that as you approach the number 49 from the bottom and you're coming up, the last number you hit that can be divided by 2 before you get to 49 is called 48. And so Aiden's exactly right. You're going to break it up into super big good guy times, leftover bad guy. So the x to the 48th is now kind of like we do with numbers, going to be the one that I circle. I'm always going to circle my good guys. What is x to the 48th when he busts out of jail? X to the 24th. So we have x to the 24th times the square root of x. Make sense? A little bit? More practice to come? All right, let's practice with a cube root. Let's do the cube root of x to the 53rd. Nope. I love that you said that because you're a great listener, but 52 doesn't help me, Ember, because you can't divide 52 by 3. Oh, I'm sorry. God, I'm an idiot. Ember, you would have been right if your teacher weren't a ding dong. I meant to do a cube root. Could you guys add on a cube root? You would have been right. I'm sorry. Like you were supposed to read my mind or something. So now that it's a cube root, how are we going to do the divvy trick? Like, what do we break 53 into? Right. And your calculator will help you find these combos. Like, some of us can do them pretty quick, some of us can't. It's okay. But it winds up being inside the cube root, we break it up into x to the 51, and then the leftover is going to be x to the 2. There's nothing in the right. Correct. Yep. So remember, yeah, like Diedrich said, an invisible index is always 2. If it's going to be anything else, like 3, 4, 5, you'll see it there, unless your teacher forgets to write it, like I did. And everyone okay with 51? Because, of course, 51 is the biggest number that can be divided by 3. That's under 53. And so 51 is going to be my jailbreak. What is 51 when he busts out? So my final answer is x to the 17th times the cube root of x squared. If you ever find yourself with your leftovers having an exponent that's as big as or bigger than the index, you've done something wrong, because that means there's more 3 packs or 4 packs that you can pull out. Okay. This time, let's do it with multiple variables, and then we'll put it all together with numbers and call it good. So this time, let's do the 5th root of x to the 12th, y to the 4th, and z to the 124th. So what's going to happen now is we're going to have lots of good guy, bad guy sort of breakup. Sometimes you can wind up with like 8 or 9 or 10 different items inside your root when you consider good guy, bad guy. So first off, the index being 5 tells us how our brain should now be thinking. We should be thinking, can I divide those things by 5? So let's talk first about, by the way, when you set these things up, You basically want to go like this. You just want to make a root and just make it long like that. And it might not even be long enough. A long root. You just kind of keep going. So what are we going to do with the 12? Nice job. We're going to bust them up into x to the 10th times x to the 2nd. Everybody see where Lane got that 10 from? We want it to be divisible by 5. What are we going to do with the y to the 4th? Leave it alone. It doesn't even have enough to make a 5-pack. Right? So I left this out earlier and I felt bad. I probably should have said something. Sometimes you can't do anything. You just like leave it. I'm not going to circle it. I'm not going to break it. It doesn't even have enough to offer one jailbreak. So it is what it is. What are we going to do with the z? Yes, we're going to do z to the 120 times z to the 4. And if you watch me teach this lesson at any point in my past or future, I will always do what I'm about to do, and you should too. Circle your good guys. It's going to help you. Like, don't do it for me. It's going to help you because it becomes a visual thing, not only of who's breaking out, but importantly also at the end, who's stuck in jail. So x to the 10th, good guy, getting circled. Z to the 120th, good guy. We have a lot, though, that are stuck in jail. All right, here we go. When you break out x to the 10th, what does he become? X squared. When you break out z to the 120, what does he become? Z to the 24th. Good. Right? And that's just division. Let your calculator help you with that. Exponent divided by index. That's okay. And then we're going to put times the 5th root of anyone that we didn't circle, you just copy back in. So who's my first inmate for life? After that, done. Now let's put it all together. You guys got this? Okay. So I think this will be our last example, unless you want more, but I think you got this. You sure were. Let's do the 4th root of 80 x to the 11th, y to the 5th, z to the 24th. So what I like to do is rewrite the problem, and I like to make the root generally at least twice as long as his predecessor. I find myself almost always running out of roof. You know what I mean? Like I think I made it long enough, and I'm like, God, I need another little bit to fit this Z or something. So just make it. It doesn't matter. It's not going to hurt anything. All right, how are we going to bust up? Well, first off, do we like the 80? Why? Right. And that's exactly what I was hoping you'd say, even though it's catastrophically wrong. And so what's happening here, and it sounds kind of mean to say that, but as a teacher, you almost want your students to make certain mistakes so that you can point out a misconception. And your misconception there is that you thought that 80 was an exponent. So now we have to go back to yesterday's lesson. I don't give a rip if 80 can be divided by 4. 80 is not an exponent. 80 is what we did yesterday. So I ask you again, do we like 80? We do not. If you look at your list, your notes thing, that power sheet that you took, I dare you to tell me that 80 is on the list of 4th rootable numbers. He's not. Who's the first 4th rootable number? Before that. 16 is 4th rootable. Does 16 go into 80? So yes, while 80 himself is not a good guy, like I did yesterday, I can break 80 up into 16 times 5. Please don't forget yesterday's lesson. When they're not exponents, it's the other stuff. Now you can commence answering questions the way we're learning today. Do we like x to the 11th? No. What are we going to bust them into? 8 and 3. Nice. Do we like y to the 5th? Nope. Y to the 4th times y to the invisible 1. And like here, again, you see I'm almost out of room. It looked like that's going to be plenty of real estate. Nope. Do we like z to the 24? We do, because 24 can be divided by the index 4. So I'm going to go ahead and leave him alone. So I barely left myself enough enough roof. And I equate this to, like, you remember the struggles we've been having, and we're not quite out of the woods yet, but that the weeks we spent talking about square, square, multiply, double. And I don't know how many countless occasions I told you guys, go get a red pen and a blue pen and do the things, or separate them. And so many of you just continued not to do it. I feel like this is a time where I can again tell you some good advice. You should circle the good guys. It will help. Promise. Just like if I give you advice, it's not because I'm freestyling, feeling some vibes. It's tons and tons of years trying to figure out what makes sense and what works. So I'm going to go through now and I'm going to circle anyone that can be fourth rooted. Like 16 is a good guy. X to the 8th is a good guy. Y to the 4th is a good guy. And Z to the 24th. This helps you on both ends now of what you have to do. A, it helps you to identify the jailbreaks, and B, it helps you to identify who's going to get stuck back in when you're done. Here we go. First jailbreak is 16. What's he become? 2. The fourth root of 16 is 2. You are not dividing by 4. You are taking the fourth root. It is not an exponent. Next jailbreak is x squared. Now you're back to dividing, go figure, because it's an exponent. Third jailbreak is just regular y to the 1. I never put the 1. Last jailbreak is, and that is all jailbreaks. And then after this, I'm gonna put a little time sign, maybe not. I kind of like the time sign. It feels like it, oh, it just makes more sense. And I'm gonna put times, and then I'm gonna rebuild my fourth root. And then the only ones I didn't circle are gonna go back in for a life sentence. Who's first? Then, and done. You got this. Okay. All right. I'm going to hand out the worksheets. You guys are going to work. I'm going to try to get those